All right, folks, it's very important to protect your hole. Today we're going to talk about applying that to the NanoVNA and the TinySA. So here's the original NanoVNA-H, and I want to point out that we had these SMA connectors here. Now what we're worried about or concerned about is mechanical and electrical protection of your hole. So if you take a look at the construction of the BNC, and I believe these were invented by Bendix Corporation in around 1960, and we use them for high frequency RF transmissions, and we put these on coaxial cables. But that said, if you take a look at the construction of this, you see that there's this little teeny tiny hole in here. And when we hook this is a female SMA connector. When we take a look at this, which is a male SMA connector, let's see if I can get this to zoom in. You can see that there's a little pin in there. See that pin? And when you put these together, that pin goes into that hole. Now, one thing that you need to pay certain attention to is that when you put this in here, you want to turn this barrel part to make your connection. What you don't want to do is you don't want to rotate when you're putting it in the hole like this. Because what will happen is that that pin will spin inside of here, and based off the laws of physics, you get some friction in there, and that will blow out your hole. And you don't want that. You want it to stay nice and tight. So when you put this in here, you just screw that on like that. Now some folks, and I'm not this I'm not this uptight, will use a metered wrench, and I think it's called a torsion wrench or Torx wrench or something like that, to make sure that you get this to the appropriate tightness. I just go finger tight. And so what I'll do is make sure that it's snug, not too tight and not too loose, and I have a good connection. Now that's probably not the textbook way to do it. You should use the wrench. But again, you want to be really careful. Now I've seen videos where people will just take like snips of bare wire or something like that and put it in here. And that's really bad because you're going to wear that out. Now, if you're mechanically inclined, you can take these apart. And then what you could do is you could solder a new connection on there, but that's a little bit of a pain. So what we have here is a solution. And then you can see that this is just an adapter that we use. And let me just unscrew this correctly and show you. And this is a BNC male to BNC female. And what I'll do is I'll put these on my NanoVNA or on my TinySA, see? And what that'll do is that I can screw things in and out of this all day long. You can just screw that, and then what'll happen is that this will wear out and not the SMA connector on your device. So that's one thing. Now something that you need to pay attention to when you do that, your ground plane changes. So if I do a calibration on these two NanoVNAs, I do the exact same calibration with the way they're configured now. My reference plane, and I might have said ground plane, so I take that back. My reference plane on this one is at the end of this SMA connector, while my reference plane on this one is at the end of this SMA adapter on the connector. Further, if I go ahead and I take something like this cable and I connect that, my reference plane has now moved to the end of this coax cable. So those are things that you need to consider. Now, I've done videos showing how you can adjust the reference plane using electrical delay in here, but I'm not going to do that in this video. The other thing I wanted to point out was that you have electrical considerations that you need to be aware of. So on some of these, you can see here, it should tell you that there is a plus 10 dBm limitation for how much power you can put in here. Now that's not too much of a big deal, but if you are using an amplified signal or a signal stronger than your NanoVNA and feeding it in here, you could cause some damage if it's over that. So it's best to keep your signals super low. It also says 10 volts DC max. So if you put DC current into these devices, you could also have a problem. I believe the measurements are a little bit different on the TinySA. It's plus 6 and 5 volts DC. The next thing I wanted to talk about, and I got to find something metallic, and I was eating breakfast, so all I've got is this fork. But if I were to take something like this, which is a coaxial connection that connects to my antenna that's out in the backyard, and I want to connect this up to one of these devices for measurement's sake, my antenna might have static electricity buildup on the antenna, and connecting that directly to one of these could give me an electrostatic discharge, which is a high-risk situation. So what I'll do is I'll take something metallic and I will short out the shield against the connector and discharge the static. Now that's probably not the safest way to do that, but that's the way we do it here. Anyhow, if you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. As always, thanks for watching.